Hello, this is Walden. Today we're starting with newcomer hemosiderin solution for LP isomers. This, unfortunately, is our slowest solution, but I think that this is easily the most unique one for this puzzle, because it's not the puzzle that I released. When I first built the solution for this, I could not for the life of me figure out why it wasn't working. I never even considered that someone might attempt to edit the input with what I guess you'd call an isomer of the original. It's rotated 90 degrees counterclockwise, as we'll see in a bit. Obviously this isn't a valid solution, so I can't award any points for it. But thanks for sending it in. You definitely fit the theme for this week, though maybe not intentionally. Here's one by Ubersolmatic. It's functional. Having to double back to pick up the hydrogen isn't the best thing, and having to travel a whole span of 6 spaces to output isn't too great either. But hey, it's double pumped. Darius Reader avoids double pumping and instead has blue follow a 9-long circuit. About half the players did that, in fact, and because of this, the solution takes a little over 90 cycles. This is our midpoint this time around. Guava Moment had a similar concept in mind. Also, his main circuits have a symbol on every space. Because of this, he was pretty convinced that there were no further improvements to make. Well, there were a few. We're back into double bump territory with this solution by Cairn. Also, for once, this is also my solution. This one, I actually put in a decent amount of effort to solve. Unfortunately for Cairn and me, this is a 9th place solution. Well, it happens. Nethris scores 8 with this carryover solution. It's also our least symbol. One of the benefits of splitting up the work like this is that you don't have to travel as far to output the molecule. Instead of moving over 6 spaces, the blue auto rotates once, and then the red auto grabs, rotates once, and moves over 2 spaces. It's a small change, but individual cycles really matter here. Speaking of individual cycles mattering, I'm apparently full of it because this solution, or something very similar, was submitted by Sudodud, Servaldrag, Zindi Minner, and Krakor in that order. It completely breaks the mold for solutions that I've seen for this one. Instead of having to move that double bond, why not just swap the methyl group and hydrogen? From the start of the puzzle to the first output it took 10 cycles, and the whole circuit is 20 cycles long for a total of 90. It's perfectly balanced, and I really wanted this to be the first place solution, but unfortunately it's not. This one isn't either, but that's still not a bad thing. The knife scores the highest he has since way back at the start of the tournament in Sun Simulator. So this is a 16 cycle circuit. That means that the average time to output a molecule is 8 cycles, which then means we've broken the 90 cycle barrier. I believe the only way to do this is if you grab the hydrogen on the right of 1-butene and then rotate twice to wind up with that hydrogen on the left. Based on the same symbol count, the solution has to be faster. That's because instead of using a flip-flop to move to this rotate then move back, we just move to the right a bit earlier. That clears up space for the Waldo to drop a cycle earlier instead of having to bond. This solution was submitted by Canniba LK9, but before that, it was submitted by Gigigal, a full 3 days in advance. Actually, Gigigal submitted this 2 hours after the puzzle was released. Hell of a job. Natural Chemo and the Chem and Space Chem taught me that least symbol isomer puzzles are absolutely beautiful to watch. Let's start with Blue-Eyed Rats. This is number 26 out of 30, but really, who cares? Just watch this run. It's relatively simple, it's got a nice flow to it, and most importantly, bond priority does not matter in the least. The knife prunes out the blue Waldo for this solution. I didn't see a lot of single Waldo solutions for this. Again, we have another submission where bonder priority doesn't matter. You'll see why I keep pointing this out pretty soon. Here's one by Alpha Raptor. I'll go ahead and point out that bonder priority doesn't matter here either, but only because, look at this. 7 bonders and the order doesn't matter? Crazy. Oh, and this part where the red Waldo, has a square-shaped path that drops, grabs, and drops again. Well, this is a really interesting idea. I'm full of foreshadowing today, apparently. Mr. Blarney does a thing where both Waldos majestically carry this oxygen and hydrogen all the way around the rest of the molecule. This is another submission just short of 8th place, but on the right side, Mr. Blarney was beat by a symbol, not by cycles. This one by leveling is almost a single Waldo solution. Something to note is that it may look like there are way too many D-bonds here, and he could save symbols by only doing bonds and D-bonds where he needs to. Well, as it turns out, he's only debonding where he needs to. This single bond command is doing the job of 3 bond commands for a net savings of 2 symbols. So, how many symbols do you think we can save from here? Well, at least 1. Nethers is doing basically the same thing as Mr. Blarney, except with 2 less symbols. The red Waldo is also timed to run circuits at twice the rate of the blue Waldo. I've never really had the patience for good timing like that. Serval Drake and Cracker gave me this one. Did you ever think that this could be completed with 2 simple loops? If you remember from before, this triple grab drop thing is very similar to what Alpha Raptor did. As Serval Drake beat Cracker to the solution by 2 days, he's the one to come out on top. Well done. On 3rd place. Leylite saves yet another symbol here, I guess because the blue Waldo gets a lot of reuse out of this single bond and D-bond. Well, whatever the reason, I'm really impressed with it. Mainly because this bonder priority is a nightmare. It took me a solid 15 or 20 minutes to recreate it because I really didn't get any instructions. There are 3 bonds that take place here, and all of them can fill for a lot of different reasons. Moving on to a much cleaner puzzle. We have Pseudodude. Again. This guy needs to stop getting 1st place. But I can't stay mad at him. I mean, look at this. A box and a line, and no bonder priority whatsoever. Well, anyway. Are you ready for some of the most beautiful symmetry you've ever seen? Because this next puzzle really puts the chem in, well, you know. If you read the information on the puzzles, you'll have noticed that every submission for this one required a chemistry fact. Because of this, I'll mostly be reading those off. These solutions really speak for themselves. First, something by carbon dioxide. Fluorine is the most reactive element. Elemental fluorine will react with any other element except for helium and neon. It also reacts with many compounds. Just as a cold gas, it spontaneously reacts with steel and glass. It oxidizes oxygen, forming the explosive compound FOOF. It even literally makes water burn. I think he's slightly off about helium and neon, though I don't think either of those would be very stable. Janderbilt may win the award for most interesting fact, at least from a data analysis point of view. Researchers are claiming that the noted decline in North American cryomates since the 90s is maybe 90% attributable to the discontinuation of the use of leaded gas. Tetraethyl lead, the additive in leaded gas, is thought to have affected the infant population in concentrated urban locations when combusted and expelled into the local atmosphere. We stopped using leaded gas in the 90s, and 20 years later, the crime rates went down. Although correlation doesn't necessarily equate causation, different areas stopped using leaded gas at different times. In all areas researched, the same 20-year window was observed. Also noted, the disparity between higher crime rates in congested urban areas and lower crime rates in rural areas has equalized, suggesting that the change was of an environmental nature. Well, I could have told you that. Cities are pretty dangerous environments. Here's Waypoint with what appears to be some information on our output molecule. 1,4-dioxane is used as a stabilizing additive in transporting chloroform. If the protective oxide layer of an aluminum transport container is breached, chloroform will normally react with the metallic aluminum casing by forming an aluminum trichloride catalyst and then rapidly decomposing into other nasty stuff. The dioxane interrupts this process by binding itself to the catalyst instead. I'm having a hard time fact-checking that, but if that's true, cool. Maybe we're making something actually useful. Guilty Bystander gives us 3 facts. 1. Noble gases aren't completely inert. Xenon, for instance, can bond with fluorine to form xenon hexafluoride. You'll already know that if you saw last year's tournament. 2. Catenates are molecules with interlocking rings that are mechanically interlocked but not actually bonded to each other. Finally, my favorite, number 3, Dmitry Mendeleev, the inventor of the periodic table, also helped set up the standard for the strength of alcohol in vodka. Gotta love Russian scientists. Karen taught me that the ins and outs of chemical engineering are way too dense to talk about in short form, so instead I'll add it to the thread later and talk about the solution. Karen did all this without using the sensor or the quantum tunnels. Also, this up and down motion that you see right there, well, I mean, it looks like it could really be simplified, but you know it works, and it creates ethylene at one point, so fine by me. Oh, you know, I guess you could create maleic acid from ethylene and carbon dioxide, I guess. I wonder if that's a real process. Quav Moment writes, there are 5 stable elements with an odd number of neutrons and an odd number of protons. Deuterium, also known as heavy hydrogen, with 1 and 1, lithium-6 with 3 and 3, boron-10 with 5 and 5, nitrogen-14 with 7 and 7. If you notice a pattern, well, ignore it, because the 5th stable element is metastable tantalum-180 with 73 and 107. Regular tantalum-180 has a half-life of 8 hours, by the way. Well, that seems like one of those facts that you figure out on your own. I mean, maybe he got it from someone else, but anyway, did I mention that this solution is particularly beautiful? I mean, look at that symmetry in action. Only 5th place though, unfortunately. Echo 2 decided to go a bit poetic. Lime once was mixed with sand to make some mortar, or building glue. Used to build a town, never gonna let it down, never gonna run around and desert you. Here's something by Chichigal, who shares with us. Tungsten is the heaviest element known to be essential to some life. No plants or animals are known to use tungsten, only a few bacteria and archaea, such as Pyrococcus furiosus. Where used, tungsten functions similar to molybdenum in plants and animals. I could have sworn someone recently said that molybdenum was the heaviest element essential to life. Maybe they meant human life. I can't imagine tungsten working well with us. Also, this is the number 3 solution, but it doesn't use quantum tunnels. Carlbunk saves the symbol and also completely avoids using quantum tunnels. He says, fissile, also baryonic matter, also known as everything listed in the periodic table, only comprises about 4.6% of all energy in the universe. The rest is in a form that has never been directly detected by a laboratory. A bit dry, but I'm sure that could make a good science fiction hook. Congrats on 2nd place, Carlbunk. And here we have Jabor's solution, with possibly the densest chemistry factoid that I received. However, he made 1st place, so I figure I should give it my best shot. The letter J doesn't appear anywhere on the periodic table of elements. Okay, with that out of the way, wow, look at this solution. It's much like Quava's, but he avoids having to carry the maleic acid down to the bottom of the reactor by opting to rotate at the end instead. Whew, I hope you guys feel like you learned something today. I know I did. Never used Jabor as a source of chemistry information. Well, next week is our final round for the Open Tournament. We have our bonus challenge for the upper tier and the new random luck challenge to look forward to. And beyond that, a closed tournament where the best players go head to head. Good luck, everyone.